In today's lesson, we're going to learn how to solve inequalities. Inequalities are math sentences that compare quantities, and these will find values that will make your variable true, not necessarily equal to each other like we did in the equations. In the box that you see on this page, we are shown the symbols for our inequalities. We have is less than, which could also be written as is fewer than. We have our is greater than symbol, which could also be written as is more than or exceeds. This is our is less than or equal to symbol, or is no more than. Or this one is at most. So this one says is at most. That means this is the biggest number it could be, but it could be other numbers that are less than it. And our last symbol is greater than or equal to. Could be written also as is no less than, or is at least, meaning this is the smallest number it could be, but it could be numbers that are larger. Okay, so off to the right here, you're going to notice our first inequality. We are going to solve these just like we've been doing our equations without the equal sign. So if you notice, we still want to get our variable x here by itself. We're adding 3, so we're going to go ahead and take away a 3 on both sides. And our positive and our negative 3 become a 0. They're opposites. All we have left on this side is an x. Now we no longer have an equal sign, but we have a is greater than sign. And then 10 minus 3 is 7. So my answer is x is greater than 7, which means that all numbers larger than 7 are really answers to this inequality. All right, let's go down to the bottom one. We have negative 6 is greater than or equal to n minus 5. So again, we're going to look for the side with the variable on it. We see the letter n, and we're going to notice that there's a takeaway 5 here. Opposite of taking away is adding, so we're going to add a 5 to this side. What we do to one side, we also do to the other, so we'll add a 5 here. These two together make our 0. All we have left here is n. We keep our symbol is greater than or equal to, and negative 6 plus 5 is a negative 1. So negative 1 is greater than or equal to n. Now, along with solving the inequalities, we also need to do some graphing with our inequalities. And we'll be graphing these on a number line. So let's go back to our original problem up here. We're going to actually draw just a small number line. The solution, x is greater than 7, that's the first number that we're going to put on our number line. So we're just going to make a little tick mark with the number 7 for our answer, our solution. And we have to ask ourselves, is 7 an answer to this problem? So if I take this number 7 and I would substitute it right here for x, 7 is greater than 7. Is that a true statement? Well, no, it's not, because 7 is equal to 7, but it's not greater. Because it's not a solution, we're going to put an open circle here. All that means is 7 is not included in our solution set. Once we determine that, then I'm going to go and I'm going to write the first number that's less than 7, which is a 6 on my number line. And I'm going to do the same thing on the opposite side to see what's the one number larger. Because what I need to determine is which side of this number line am I going to shade in to show that those numbers are answers to this problem or solutions to the problem. So I'm going to go to this number 6 and I'm going to substitute it right here for my x. And I'm going to say to myself, 6 is greater than 7. Is that a true statement? Is 6 greater than 7? Well, no, it's not. So we're not going to do anything to this side of the number line. Then we go to the other side and we check our second number. We have an 8. So I would put that right here where my x is, and I have to ask myself, is 8 greater than 7? Yes, it is. And because it is, I know that all the numbers on this side of the number line are going to be solutions to this problem. And therefore, I'm going to shade in everything from the number 7 and larger. So that tells me that all numbers on this side of the number line would work for this inequality. All right, let's go back down to the second problem that we did previously, and let's draw our number line. And it says -1 is my solution. So right in the center, I'm going to put a -1. And I'm going to ask myself, by putting up -1 in here for n, is -1 greater than or equal to -1? Well, yes, because -1 is equal to -1. So because I include this -1, I am going to put a closed circle. That tells everybody that that number 1 is a solution to this inequality. And then I'm going to go before it. 1 less is a -2, and 1 past it is a 0. And then I do the same thing that I did on the first problem. I ask myself by putting in a -2 here for n, is -1 greater than or equal to -2? Is -1 greater than or equal to -2? Yes, it is greater. So we're going to be shading in this side of the number line. And then I'm going to double check, and I'm going to put a 0 here. Is -1 greater than or equal to 0? No, it's not. So that is another way to check to make sure that that side is not colored in or shaded in. So open circle, number is included. And then a closed or shaded in circle, the number, oops, I did this wrong. Let me insert here, is not included. Number is included. All right, so an open circle, it is not included in our answer choice. A closed circle, the number is included. All right, we're going to go down and try a word problem on this one. Dylan has $18 to ride go-karts and play games at the state fair. Suppose the go-karts cost $5.50. Write and solve an inequality to find the most he can spend on games. All right, so we know that he has $18 to spend on games. So I'm going to put that over here as my answer. I know he's going to spend $5.50 on the go-karts, but I don't know how much he has to play games. So if I am going to find a total amount, I know it's going to be an addition problem. So $5.50 plus some number. Now let's see, he has $18 to spend. Can he spend more than $18? No. Can he spend exactly $18? Yes. So I know it's going to be an is equal to. I know he can't spend more, so he has to be able to spend less than $18. So $5.50 plus some number is less than or equal to 18. Okay, so the most he can spend is $18. So in order to solve this, again, we're going to get our x by itself. So I'm going to subtract the $5.50 from each side. And these two are opposites. They're going to become a 0. So my x is less than or equal to 12.5, which means the most Dylan can spend on his games is $12.50. So he can spend $12.50, or he could spend less than that if he chose not to spend all of his $18. And that's how we go about solving inequalities.